This is the chemistry week 11 MS quiz. It's really easy today, not that hard. Part of it's a repeat, so it shouldn't be that hard. So, which of the following are diprotic acids? So, you could take the part di, and you know they're acids. What does diprotic means? It just means what acids have two hydrogens. So, when you see H2 or 2H, you choose it immediately. So this one has H3, or well, 4 H's, so it's not a diprotic acid. This has H2, so it is HCl, only one H, 2 H's, so you choose anything with 2 H's when you see the word diprotic acids. That's it for the first question. Moving on to the next. Which of the following is a neutralization reaction? We know when you have a neutralization reaction, it means that you're reacting an acid plus a base. And when you act an acid with a base, you're gonna get a salt. Most times, sometimes you won't. And you're gonna get water. And for the net ionic equation for a neutralization acid, it's always gonna look like this. So this is your only correct one. This is wrong because it's a complete reaction, first of all. Second of all, we do not have water here in our product, so no. We don't have water, no. We don't have water, no. We don't have water, so no. Only when you see water in your product can you consider it. Next one. Here, when can you prepare soluble salts? When you add acid on a base, yes, that's one. When you add acid on a metal, yes, that's one. When you add a base on a carbonate, no. This should be acid on a carbonate. So no, this is wrong. Base on a sulfate, first of all, we never add bases on anything, and sulfate is definitely wrong. When you add an acid on a basic metal oxide, yes. So when you see it as metal, or as a base, or as a metal oxide, or as a metal carbonate, and there's an acid reacting, you choose it. Here they're telling us you put HCl on CaCO3. We know that when you add an acid to any carbonate, you're gonna get bubbles, and that the acid and carbonate reaction gives off effervescence of carbon dioxide and water. Anytime you see a reaction with a carbonate, these are your two products. This is Haber processes. When you want to increase the yield of ammonia, we need 200 atmosphere and 450 Celsius, and the catalyst is always iron, and catalysts increase their rates but have no effect on the yield. This question, old and memorizing. This question here, they're asking you for the chemical formula of product A. So whenever you see SO2 plus O2, it's immediately making SO3. It's like without a doubt making SO3. So just put it in immediately. And this, also memorize it. It's always 2 atmosphere, 450 degrees Celsius. It's always 450 degrees Celsius in any of the Haber processes or the contact processes. And then you have vanadium 5 oxide will be our catalyst for sulfuric acid manufacturing. Here, look. You need to see which ones are weak acids. Whenever you see COOH, it means it's a organic acid. Organic acids always are weak. Anytime you see it HCl or HNO3, we know immediately that these are really strong acids. NaOH is a base, so we cancel it out, leaving us with these three. Personally, I'd memorize them if I were you. Here, they want the strong bases. This, we just said it's a strong acid. This, it's also an acid because it doesn't have an OH or a O in it. This, also an acid. Don't say, oh, we have an OH. No, look. When you see this ending, it's an organic acid, so no. HCl, we also just said it's an acid, so KOH and NaOH are strong bases. Anytime you see anything from group 1 with OH at the end of it, it's a strong base. Here, this question, personally I'd memorize it. Mg is a metal, metallic acids are basic, metallic oxides are basic. And then you have CO2, it's acidic because C is not a metal, non-metal. Cu is a metal, so it's basic. N2O is one of our special cases, so is CO. So they're both neutral. ZNO and Al2O3, always amphoteric. SO2, S is non-metallic, so it's acidic. And then CaO, Ca is metal, metallic, so it is a basic oxide. Okay, so here, anything before 7, acid, anything after it, base. Anything at it, neutral. So A is before it, so acidic. B is at it, so it's neutral. Anything C and D are both after it, so they're both basic. So for this question, look, here's what you're gonna do. We know when they give you the pH that the concentration of H plus molecules would be 10 to the power of negative whatever the pH is. So here, if the pH is 5.360, our concentration of H is 10 to the power of negative 5.336 or 360, whatever you want to put it. So since now we know that this is our concentration of hydrogen ions and we need to find OH, we know that to find the concentration of OH minus, you need to do 10 power 14, which is our Kw, over concentration of H plus. So once we do 10 power negative 14 over 10 power negative 5.36, we're gonna get it to be equal to this number here when you put it in your calculator. That's it. You don't have to think about it much. Here, also not that hard. Let's solve. Wants to find the concentration of hydrogen ions in a hydroxide solution. You have 0.400 m of a strong acid, H2A. So what this means that when you disassociate it, you're gonna get 2H plus, which means you're gonna have to multiply whatever your concentration, or whatever your concentration of H is, by 2 times 2. So 0.400 times 2 equals 0.4 times 2 equals 0.8. For this part, you just take this value here and you do the same like you did last time, 0 times 10 power negative 14 over 0.800 equals 1.25 times 10 power negative 14. And that's it for this question. Calculate the concentration of hydrogen ions in this aqueous solution of KOH at 25 degrees Celsius. So like we said, when you want to calculate H plus in a solution of KOH or basic, 10 power negative 14 over whatever concentration they give you. Be careful if they tell you it's 2OH or something like that, because they brought it in the periodic and many people got tricked. This is equal to this answer when you put it in your calculator. Be careful to two significant figures. Here, same thing almost, but here we need to apply our rule N equals CV. We took this last year. So we need to find H plus. Here they gave us an acidic solution, so we do this. So you do 0.08 divided by 250 milliliter. It has to be in liters, so 250 times 10 power negative 3. When you do this, you're gonna get 0.32. And then to find pH equals negative log of your concentration of H plus. So negative log of 0.32, which is going to give you this answer. By the way, I have to show you something. When using negative log, I prefer if you use this negative. Wait, can I draw? Yeah. This negative over here. Don't use this one. Our miss told us that sometimes you might get a different answer, so preferably always use this one. What's the difference? I genuinely do not know. But yeah, that's just a little remark. Okay, my phone needs to shut up. Okay. Now, best method to obtain ZnSO4 when H2. Okay, so look, ZnSO4 plus H2SO4 is gonna give you. We need to put like terms alike. So inside plus inside gives you outside plus outside. So yeah, look. You're gonna have, what do you have in the middle? Right in the middle. Where did I get ZnSO4? What? Oh my gosh. Blind. ZnO, sorry. So what do you get in the middle? H2O, right? And then anything else is ZnSO4, which is a salt. Since this is a salt and you have water, which is H2O, you need to get rid of the water, and the only way to do that or get rid of water from a salt is crystallization, mostly. Okay, so when you mix NH4NO3 plus NaOH and you heat it, a pungent gas is released, which means it can only be ammonia gas, and ammonia is a basic gas, so basics turn red litmus paper blue. We know this already. Especially we should know this after the periodic we had last week. To prepare PbSO4, equal quantities of PbNO3O2, you're gonna ask why did we choose this one? You always try to choose anything that's with the ones that are always soluble based on solubility rules. So nitrates always soluble, so you choose this one, and NaSO4 because sulfates aren't usually soluble, but Na is soluble with everything, so that's why we choose this one. And we have to use the precipitation reaction because you have an insoluble salt. When you have a strong acid and a strong base, they react in quantities that contain equal number of H and OH. When you see the word equal and H and OH, it's neutral solution. That's it. Neutral salt can be prepared by mixing. With a strong acid, you need a strong base to make anything neutral. A solution is made by adding sulfur trioxide. So sulfur trioxide is a acid, I think. Yeah. And then to water. The water's pH, we know it's 7. And it'll turn it to 1. One HCl solution, well, you always have to have an acid reacting with calcium carbonate to produce CO2. So, yeah. Now let's move on. So when sulfuric acid, it's a strong acid. When you're added to sodium sulfite, SO2 gas will be released. Sulfite is SO3. So you need to displace one of those, and sulfuric acid is, I forgot to be honest. Anyways, whenever you add a strong acid, like sulfuric acid, to a sulfite, you're gonna get SO2 when heating it. So just know that. And whenever you want to get NH3, you need to add a strong base, to anything with ammonium, which is NH4. And oh yeah, that's the end of the quiz. Hope you understood everything. Bye.